ethers also today, or phenol, one of the topics. Alcohols, as you all know, are the compounds in which OH group is present. And as a functional group, there has to be OH group present in it. Now, classification, you should know that it is classified as primary, secondary, tertiary. Physical properties of alcohol. Extensive H bonding is possible, though less than carboxylic acid. But yes, as compared to alkyl halide, ethers, hydrocarbons, very good hydrogen bonding. And due to their capacity to form hydrogen bonding, they have high boiling point as compared to aldehydes, ketones, ethers, hydrocarbons, etc. Okay. And due to their hydrogen bonding, they are also water soluble. Okay. In fact, they are highly water soluble. We'll see that if we observe their general properties, lower molecular weight alcohols are in fact miscible in water. Methanol and ethanol are miscible in water. With increase in molecular weight due to increase in carbons, boiling point will increase, but water solubility will decrease. Why? Because the hydrophobic part of that alcohol is increasing if we increase the molecular weight and keep the OH same. There are two cases. Once you can increase the molecular weight by increasing the alkyl weight. Other, you can increase the molecular weight by increasing the count of OH. So if I increase the count of OH, then my water solubility will definitely increase too much. And so will be the boiling point. Both will increase. Okay. But if I increase the hydrophobic part, what is the hydrophobic part? The alkyl part. Then my water solubility will decrease, though my boiling point will still increase. Correct? So that is how we observe the change in boiling point with increase in molecular weight. If the alcohols are isomeric, for isomeric alcohols with branching of parent chain, 1 degree better than 2 degree, better than 3 degree. This is in general valid. With branching also, boiling point will decrease. And similar is the behavior. 1 degree alcohol is having a higher boiling point than 2 degree, then 3 degree. But remember this to apply only for isomeric, not in general. I'm not saying in general any 1 degree will have higher boiling point than 2 degree. No. When they are isomeric, only then this point will be valid. With increase in number of OH groups, water solubility, I have already told, increases, boiling point increases. Now see the drastic change in boiling point from ethanol having 1 OH, 78.3. Okay, yes, with increase in OH, there is increase in molecular weight, I agree. But from 78.3 to 197 degrees centigrade, the increase in molecular weight versus the increase in boiling point is very high. Okay, so too high increase in boiling point. When we go to glycerol, similar is the observation. Roughly, if I say roughly, I'm not saying exactly, with increase in OH, I can say 100, rough estimate, 100 degrees centigrade boiling point is increasing. Of course, not exact, we are general saying. Okay, and see, if I go to propanol, there is increase in molecular weight, right? From ethanol to propanol, if I compare these, see 78.3 and 97 degree only, though there is increase, but the increase is not as prominent as the increase with increase in number of OH groups. Is this observation absolutely okay? I think all of you have taken care of it. Methods of preparation. Now, methods of preparation, we have already done these in past weeks, like in alkanes. We have seen all alkanes are inert to KMNO4 oxidation, except this one, which has 3 degree H. This 3 degree H is oxidized to OH with KMNO4. Okay, from alkenes, dilute H2SO4, there is OH, Markovnikov addition is followed. In alkene weak, we have done. In hydrocarbon weak, this complete slide has been taken care of, right? Hydroboration, oxidation, anti-Markovnikov addition of water. Markovnikov addition of water can be achieved by oxymercuration, demercuration, mercuric acetate in water followed by NaBH4. Then you have a Markovnikov addition of water. ठीक? By Bayer's reagent. Now, Bayer's reagent, what is Bayer's reagent? Again, hydrocarbon weak, whole dilute alkaline came in 4. It was the test of unsaturation for alkenes and alkynes. I'm not talking this week about alkynes because the topic we are doing is alcohol. So only for alkenes, I'm saying if I take this reaction with alkenes, I'll get the vicinal diols, which are colorless. Okay. Ag2O or peroxy acid or CF3CO3H or H2O2, these type of reagents can also cause epoxidation. But remember, if on arrow they write only Ag2O or only CF3CO3H or only H2O2, then do not assume that they are taking hydrolysis. Stop the reaction at epoxidation. Okay. For hydroxylation, they have to mention in the question one extra arrow or one extra step in which they say acidic medium hydrolysis is done. Okay, not without that you will take the hydrolysis. If they write on arrow only Ag2 or only any of these reagents, you stop the reaction at peroxy. Out of these, if I say, I heard somewhere that except this, all of them normally add that proxy oxygen, nascent oxygen, to the more substituted double bond. Okay, they add it to the more substituted double bond. Is that clear? ठीक. H2O2 basically in general as a separate, so we do not use. We usually use it when our double bond is normally in conjugation with carbonyls. There it is more, I would say, a preferred reagent. In presence of OH minus we take. So basically it is not H2O2 which attacks, it is hydroperoxide ion which attacks. And then we take here epoxidation instead of Bayer vinegar. Epoxidation is observed. That is special about that particular thing. Is that absolutely clear? This is how it is used. Then we take bromine water. So if we take bromine water, how is it part of this week's syllabus? Because when I say water, I have this halohydrin, na OH is there. So that is why I'm considering it that halohydrin OH can be introduced by bromine water, or they can write instead of bromine water, you can have HOBr, and overall it is a Markovnikov addition of HOBr, like Br positive and OH negative. That is how it will be added. This is not syn addition, okay? I don't know why I read. It is anti-addition only. It is not syn addition. It is anti-addition only. Okay. Overall, it is anti-addition of OH and Br by halohydrin because cyclic bromonium is formed and then water attacks from backside. So overall, it is an anti-addition reaction. From alkyl halides, you can have alkyl halide plus aqueous NaOH will give alcohol. Okay. Again, last week only we did SN1, SN2, aqueous KOH. So if it is 1 degree, 2 degree reaction is SN2. If it is 3 degree, then it is SN1. Those type of things we are saying that it is formation of alcohol. From ethers. Now from ethers, we'll do much detail in just after alcohol ether. So we get with concentrated HI, alcohol and R-I. And dilute H2SO4 also we can get alcohol and alcohol. But that I want to take in much detail. So not saying much here. Is that clear? Now see, whatever we did that alkene reactions, by that intramolecular reaction based questions have been asked. Okay, how to approach such questions when a molecule has more than one site, more than one places for attack of H plus. So always remember the approach is form both possible carbocations on paper. See, carbocation from alkene, whatever you get, carbocation from alcohol, whatever you get. You draw all possible cases. So from here, when I drew from alkene, stable should be at every place. So I got this 3 degree. Then you see what is the intramolecular possibility of attack. So OH can attack. I got this product. You just draw and wait. And then draw the other one. Carbocation from alcohol. So okay, this is also 3 degree. Now see, both sides I was getting 3 degree. Anna? So that thing is not making much of a difference for me that involved carbocation is less or more stable. Both were giving me 3 degree. So once I got a 3 degree carbocation, alkene should attack in a manner so that again a new carbocation should be stable. So I found, right, this way. I got this positive plus here, right? There is a possibility that I could have had a rearrangement and a 6-membered ring could have been formed. Or at this stage only attack could be there. Okay, I had 2 possibilities. So as I see, the C option is from this, and there is no further option of 6-membered ring in this case. So you just seize your question at C option. Is that absolutely clear how to approach such questions in which there is a possibility of more than one carbocation formations? Okay. Now, if it would have been a case of 6-member, let us assume that could be there in your mind that what if this was there. So let us draw. So if I take this type of carbocationic rearrangement, I'll get a 6-member ring. I'm getting plus here. And this type of structures we are getting. Is that right? Now there is not much difference in 5 and 6-member ring as per strain is concerned, but my carbocation stability is decreasing very, very much. See, here I was having 1, 2, 3, 4, 5, 6 and 7 alpha H. And here I am having 2 alpha H. And it is not that they are comparable in terms of plus I. Not that much also. Right? So I was going from 3 degree to 2 degree. There has to be some increase, some factor that is giving me extra stability. If I take further rearrangement also, that is a next step and is not that stable. Okay. So this anyhow will be one of the major important considerable product. Now similar question. When I said don't take here 5 to 6, you may misinterpret ki okay 5 to 6 rearrangement should not be taken. So immediately I am making my point that I didn't say that don't take. See here, the relative stability is being increased. See, this is not a carbocation which is of extreme stability. This is a 2 degree carbocation with only 3 alpha H. And when I'm having this expansion, I'm having a 3 degree carbocation with 1, 2, 3, 4, 5 alpha H. So there is strain to release high and I'm having increased stability. So this expansion you will take. I hope there is no confusion if you see. And of course, the best is the option kya hai, that is of always a criteria. Always keep your eyes open. What are my possible available options? As per that you decide, it would be relatively easier for you to go ahead. Is that okay? Right? So both the cases I have added in the notes, you can study it further. Now see, again a question where they did not take any such expansion, contraction things. Let us see what happened in this question. I am taking all these close questions. H3PO4 at 120 degrees centigrade. High temperature it means. So definitely elimination is what I should take. But where? So if there is a carbocation, you may wish, should I take a ring expansion? But 6 to 7 is not a good choice. Plus, there is no option for 7. Okay, keep your eyes open. So if I go by this, I will be leading nowhere. This alkene, if I go by rearrangement to shift of hydrogen, I lead to this. Then alkene is this. Okay. Then they are saying hydroboration oxidation. Answer is this. This is our P, which is obvious. Hydroboration oxidation, HBO, will give you anti-Markovnikov of addition of water. Is that absolutely fine? So we are having here anti-Markovnikov of addition of water. And thus the answer, which answer is coming? Let me see. Fourth. Fourth is matching with our choice. So these are the comparative questions of how to handle expansions, rearrangement in the options. Okay. You can definitely prepare alcohols using Grignard reagents. We have done this in our, I think, Tuesday class. This entire slide we have done in Tuesday class. So I leave it to that. I have again tried to repeat them. You can read through these or you can use them as your short notes. Okay. New method, that are this week method, never learned before. Coming to that. So the new method this time is called pinnacle formation reaction. That is formation of pinnacle. Okay. When I talk formation, first you should know pinnacle. This is not pinnacle. Pinnacle is particularly when R, all the four are methyls, then it is called pinnacle. Okay. When all the four alkyls are methyl, then this is called pinnacle. So magnesium releasing magnesium 2 plus and 2 electron, as we did in Grignard. But in Grignard, the del plus was the alkyl halide. Here the del plus is the carbonyl. That is the difference. So if you add that electron in the Grignard class, I told you this thing, that if it is positive and we add one electron, then we will get R dot. If we add one more electron, then we get R minus. Right? We have done this in Grignard class, where I also told you a word called Ampolang, reversal of polarity. Now here we are not adding 2 electron to per mole. This C del plus del minus, this C plus is having 1 electron. So C dot and O minus. Okay, this is C dot. Now 2 C dot when combining like this. Right? It is a simple like this collision and forming two radicals combining, forming a dimer. Okay, so we got this. Now see, if there would have been any more place where I could have added electron, I would have done it. But as there is no further addition possible, there is no more del plus possible. So I will just stop it here and add water. And when I add water, see OH, OH is there. RCROH, RCROH, OH. So this is how my vicinal diol is formed. Is that absolutely clear? This you can take on any ketone. If I start with acetone, if I start with acetone, then by this reaction, I will get pinnacle. Okay, the word pinnacle is when all these four are methyls. Is that absolutely okay? So this is how we can use the reaction. Yes, similar reaction could have been with esters also, but that is not part of as such this week's syllabus. I'm just giving you an idea that if same thing RCOR dash, if I want to do with magnesium in dry ether first and then followed by water, what will I get? Let us see. So same thing you will start solution बनाएंगे. So we'll start with same, that magnesium is having magnesium 2 plus 2 electrons. Right? So this RCOOR dash plus again 2 will accept 2 electron. This is also del plus. So you will have RCOR dash O minus dot. We have two such species. They will collide together. O minus OR dash C OR dash R O minus. Okay. Now when they go back, OR dash is gone. When they go back, OR dash is gone, because always acid derivatives, right, want to behave like, again 2 electrons are added. So RC dot C dot R O minus O minus. Though this is just for explanation I am using. How could it be possible that two vicinal dots can survive? So what actually will happen will a bond formation. And we will not have this. We'll have this. So till here magnesium was balancing the charge. Now there is no such polar site or polar bond where I can further add the electron. So now I am going to water. What will I get? Let me complete double bond COH OHR. And this is Otto. RCO CHOHR. So we are not getting exactly alcohol, but we are getting alpha hydroxy carbonate. No need to learn what is the reaction name and all this. Just see what is the mechanism. Okay, all of you have seen how I have done the mechanism. Here also, just see what is the mechanism. I don't want you just cram the word pinnacle formation, pinnacle. No, how we can do this. And I want all of you to attempt this question. You can do it later. Like this. And if they give same thing, magnesium in dry ether first, and second they give dilute H plus or H3O plus. Then what will you form? Intramolecular reaction is what you have to take. And as I'm not writing anything, you will take hydrogen. Okay. By reduction of aldehyde, ketone, carboxylic acids and their derivatives, you can prepare alcohol. Please take screenshot of whatever is coming on your screen because this is important. Okay, acids are not reduced by metal hydrogen. Acid chlorides are reduced by RCH2OH. Now, esters should be taken or not taken. For that, give me just 1 second. Okay, I want you to see something that how it is given in NCERT book, and that is what we'll follow. Give me 1 second. In carboxylic acid chapter, it was there. Aldehyde, ketone and carboxylic acid. See, this is the physical property. Okay. This is preparation. No, I want chemical reactions. Reduction part of alcohol. Here is the reduction. Let us read this. Okay, I want you to check what language they have taken. Carboxylic acid are reduced to primary alcohols by lithium aluminum hydride or better with diborane. Diborane does not easily reduce functional groups such as ester, nitro, halo, etc. Sodium borohydride does not reduce the carboxylic group. That is it, and that is all they have written in chapter alcohol. Oh, sorry, carboxylic acid. Okay, here they have given just this language. Whereas if I go to their alcohol chapter, let me go to their alcohol chapter, structure, preparation. Okay, alcohols from phenols, alcohols from carboxylic acid and acid. Let us read here. We should know what is given because at one place they have given something that can confuse you. So by reduction of carboxylic acids and ester. carboxylic acids are reduced to primary alcohols in excellent yield by lithium aluminum hydride. So that statement they continue that you have to reduce carboxylic acid by LH, as it was given in carboxylic acid chapter also, a strong reducing agent. Fine. However, LH is an expensive reagent and therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohols by converting them to esters, followed by their reduction using hydrogen in the presence of catalyst. Now, here they have not defined the catalyst. They have just said catalytic hydrogenation, but here they have not defined the catalyst. And in absence of that line, that catalyst is not defined, we get confused that what should we take? Should we take metal hydrogen here as a catalyst? Nickel hydrogen, if they give, should I take the reduction or not? You got my point? So don't take my advocacy or whatever I'm saying. Don't take reduction of ester or alcohols by this by metal hydrogen. And why I'm saying that, I will tell you if what is my background of that statement. Only that will give you a clear picture of what I'm saying. 2011, 2013. Let us go to 2016. 2016 was, I think, the year which is a problem, and how they have asked. Okay, just give me 1 second to reach that. I did not find it here. And I very strongly remember it was a 2016 question which should be known to you all. Just watch out for 2016. Till now, nothing. 2016. I got it. This was the 2016 question. A little blurred is there, but can you all see? We'll see the answer later. Don't worry. Just see what they are doing. See, they are having ester here, and they are not converting ester in the product. Okay. Reagent which can be used to bring out the following transformation. Matlab ester should not be reduced. Acid not reduced. Okay. Epoxy not reduced. Aldehyde is reduced to alcohol. Only aldehyde is reduced to alcohol. Now NCERT said ki go for go for catalyst and hydrogen, not defined. In that, you may go for nickel. That could be misleading. So please don't get misled by that particular line. They have not defined and left us confused. Let us check what was the answer for 25. Answer was CD. Okay, 25th was CD, exercise 2A, CD. Which page we were on? I guess we were on this page. CD, CD, CD. Was it CD or BC? What did I see? I forgot. I forgot. CD, I guess. You must be remembering. And coming to options, lithium aluminum hydride, of course, acid and esters not to be reduced. So lithium aluminum hydride is not my target. NaBH4 is good target because aldehyde is reduced to alcohol. So fine. BH3, no, because I just showed you NCERT in which it is said carboxylic acids are excellently removed by diborane. So BH3 should not be taken. NaBH4, true, we just read that it reduces aldehyde ketone, not acid derivatives. Nickel hydrogen. Now, if that NCERT line was correct, they should have not taken this as an answer. Ester would have been reduced, acid would have been reduced. See, they have taken this answer. CD was the answer, na? Nickel hydrogen. So they have used do not reduce acid and ester. This is why I want you to use this particular statement, what I just told you in the start. Okay, how to reduce them to alcohol. I hope that things are clear and you're not confused. Where is my note? Here we were. We were here only when I was saying what to use. So now you all agree? Because otherwise you may be confused that there it is given. Esters are not reduced by nickel hydro. We are defining our catalyst. Na? Nickel, palladium and palladium do not have this reduction. Yes, they reduce acid chloride to alcohol. Amide not reduced, anhydride not reduced. Only acid chloride is reduced by metal hydrogen. Aldehyde ketones very much reduced to 1 degree alcohol and 2 degree alcohol. Okay? By LiLH4, I can reduce all of them. Like all of them, I meant the acid chloride, ester, anhydride, two alcohols, aldehyde ketone, two alcohols. But very important, amides will be reduced to amines. This is not the answer. It is finally reduced to RCH2NH2. This is my on the way thing form. This I can use for explaining the mechanism. And this is formed on the way, and ultimately final product jo hota, that is product is amine. Okay. Coming to sodium borohydride. Sodium borohydride is much less of a reducing reagent. It does not reduce acid. It reduces acid chloride. It does not reduce ester, amide, anything from the acid derivative series except RCOCl2 alcohol. Aldehyde ketone, of course, specifically very well done by sodium borohydride. B2H6, best reducing reagent for carboxylic acid because it does not reduce so many other functional groups like nitro, ester, and all those. And amongst this also, if I talk, this rate is slower, faster, and relatively slower. So if I have both, I will reduce acid faster than aldehyde and ketones. Is that absolutely okay? Is this fine? Chemical reactions of alcohols. Now, chemical reaction of alcohol can be split into two. One where it has the oxygen donation, amphoteric nature, other where it donates H+. Okay, one where it donates lone pair, that is basic nature, and one where it donates H+, overall it behaves amphoteric. Okay, we have already done a lot of such reactions, dehydration of alcohols, dehydration of alcohol forming ethers, right? Reaction forming alkyl halide, all these things we have just done last week only, na? That how this protonation and then water is removed. I hope all of you are okay with this, that PCl5, PCl3 reduction. Right? I hope all good. Is anyone having any problem with this? No, SOCl2 we had how SNI is there. With pyridine as a solvent, you will have SN2 as a dominating reaction. Okay? Yes. Most stable product of the following reaction is most stable. Now see, alcohol and tosyl chloride. This is tosyl chloride. You can write it as TSCl. Okay. Here you will lose H. Here you will lose Cl. Tosyl chloride. You will lose H and Cl. So what you will have? CH3 like this. SOO, right? And this thing will remain on wedge. That we have to take care. That this, I don't want to change anything. Right, because the reaction is not of the chiral center. This was on wedge, this is on wedge. So tosylate is formed. Okay, we have got tosylate. Now see, OH was not a good leaving group. Now Cn minus can attack here and will remove this. And this is SN2. Okay, this is SN2. So now I will have Cn here, which is on dash. Right? Now we have to select both on wedge, not possible. This is the same thing, both on wedge, both on dash, because we can see one is on wedge, one is on dash. That is one approach you can do. Wedge dash words you can use, Or you can simply find the RS. I have taught you in isomerism na, that if veg dash is given, what is the shorthand to apply the RS? You go by that and you get the RS checked in these 1, 2, 3, 4 options and select the one which is matching for the RS. That is the safest way, I would say. Okay. Now, concentrated HBr and product is. This is again a question which is like conceptually. I have taken only those questions which are conceptually leading somewhere, not like collection of any random questions. Concentrated H. In advance, I could not find those single concept questions. Okay, they are in the sequence. So I am not taking advanced much of a question. Wherever I need, I take. But I'm not taking like advanced questions pehle lo. What I want to communicate, that type of questions I'm searching. So concentrated HBr. Okay. So as I told you that how to form a carbocation. Alkene, if I form a carbocation, it won't be that stable if I form a carbocation from alcohol because it is resonating. So I got a alcohol carbocation. I'll have a resonance and we'll add a Br. That is the simple basic thing we are doing. Okay, conjugation we are using and we are doing the question by that logic. And so was the answer. Nothing different or nothing special was there. It appears that what I am forming a full carbocation, but maybe it could have been a possibility that it was a direct SN2 dash also. Okay, because of this, there could have been some decrease in stability of carbocation. So it could have been a combination of SN1 dash or SN2 dash. Clear? Now the new and the important reaction, oxidation of alcohol, extremely important. Okay, so please do it carefully. So oxidation of alcohol, if I just introduce it that how to do it. First, we are removing simply these hydrogens. 1 degree, because oxidation is removal of hydrogen or addition of oxygen. Two are my choices. Okay. Here I am removing this hydrogen as nascent hydrogens. I am getting aldehyde. If I have a sufficiently strong oxidizing agent, there is a 100% possibility that further oxygen addition will take place and I'll get acid from 1 degree alcohol. From 2 degree alcohol, I am getting ketone. Now, further oxidation, if I want to do from this method, it is difficult. Okay, it is possible, but extremely difficult because carbon-carbon bond is to be broken. And carbon-carbon bond is not that easy to break. So difficult, only under vigorous condition or strong oxidizing agent something is given, then you can have that particular oxidation, breakage of this bond. Otherwise, reaction will stop at ketone stage. Here, next comes the 3 degree alcohol. Now see 3 degree alcohol, I don't have any such hydrogen to remove. So I cannot have that direct oxidation of 3 degree alcohol. That is not possible. Even if I observe under vigorous condition for 3 degree alcohol, it is usually dehydration followed by oxidation, not a normal oxidation. Reagents, what type of reagents? Now remember, I am splitting the reagents in like chromiums, whatever the choices are for chromium as a reagent. And in chromium, they are all chromium plus 6 compound, K2CR27, K2CrO4, acidic basic condition. Then we will go to next set, which is manganese compounds. Then we'll go to catalytic dehydrogenation oxidation. So that is the sequence we are taking. Okay. So let me go to chromium compounds. Now, if I talk of oxidation by chromium compounds, now chromium compounds, chromium plus 6. Primary alcohols, if solvent is aqueous condition, then they will form acid. And if the solvent is organic, then you will form aldehyde. Yes, there is mechanism, there are explanations, but the conclusion that you need to keep in your mind is the important thing, not just important thing. It is very, very important thing. Okay. Is that okay? So let me repeat what I am saying. I'm saying that if I have chromium plus 6 as a reagent and it is dissolved in aqueous condition, then from 1 degree alcohol you form acid. If it is dissolved in organic solvent, then you form aldehyde. 2 degree alcohol, whether chromium plus 6 is in organic or aqueous solvent, you form only ketone. I just told you oxidation of ketone further हर एक के capacity में नहीं, not possible for any usual reagent to do. So we'll stop at ketone. Tertiary alcohols, chromium plus 6 in organic or aqueous solvent, usually I'll say no oxidation. When some rare oxidation, that I'll explain how, when, why. So what are my reagents? Name you need to remember, PCC, pyridinium chlorochromate. Pyridinium chlorochromate, pyridine plus HCl plus CrO3. This is what you can find on the arrows, or you can find this structure. See, pyridine and HCl, I have made reaction. So pyridinium, and that chlorine we have added here, chlorochromate, pyridinium chlorochromate. Okay, this is pyridine HCl CrO3 or pyridinium chlorochromate. PDC is pyridinium dichromate. Pyridinium dichromate. K2Cr2O7 we write na, instead of that K2 potassium I am writing pyridinium. So pyridinium Cr2O7 2 minus, H2Cr2O7 in acidic aqueous conditions. Okay. Now what I was saying, that sometimes you may find this type of oxidation, but that is a rare possibility. And only if they give you some hint or something, then only you take this thing. Let me tell you what I'm saying. Like they say H2Cr2O7, okay, and they say strong heat. Now conditions are acidic, heat is there. So what actually happens is they undergo dehydration and then they take oxidation of this. Now aldehyde, na, so I'll take it to acid and like this. This is what they sometimes do, but not always. है ना? If ever in question they do 3 degree alcohol ka oxidation by reagent, then check is the condition acidic. Because in acidic conditions, they convert it to alkene and then do the oxidation. So that is like not the oxidation of alcohol directly. Okay. So वो check करना question में, अगर लगे कि कर रहा है तो कैसे कर रहा है. See, in the given reaction, see this sequence, so very relevant for this week. K2Cr2O7, yes, double bond O ketone is formed. Grignard this week's syllabus, we'll add Grignard. And then H plus heat. So I will form carbocation, but alkene will be formed this side only na, in conjugation. Now question was the number of sp2 hybridized carbons in compound X is 6, 7, 8. Okay. But see the sequence this week, relevant sequence is there in this question. Okay. Next set of oxidizing agent we have is of manganese compound, and manganese compounds are usually stronger oxidizing agents. Okay, they are stronger oxidizing agents than chromium ones. So KMnO4 under acidic or alkaline, both conditions where we are saying can oxidize 1 degree alcohol always to acid, 2 degree to ketone, 3 degree again no reaction. But again, if acidic condition KMnO4 and strong heating is there, then through formation of alkene, you can have 3 degree alcohol oxidation. But that is a very specific question based condition. I cannot generalize that this will be always a case. Sometimes there might not be such hydrogen or availability that you can form an alkene, then you can't do. Sometimes temperature is not sufficient, then you can't do. So I cannot generalize that in notes. That is more of a spontaneous approach as per the question when you come across. Is that okay? Now, oxidation by catalytic hydrogenation. This was the third thing. And in catalytic hydrogenation, we use either red hot silver or red hot copper. Temperature is certainly very high. We pass gas of alcohols, vapors of alcohols on this red hot metals. Either you have silver or you have copper. If it was a 1 degree alcohol, you will have dehydrogenation and aldehyde is formed. If it is a 2 degree alcohol, then dehydrogenation and ketone is formed. And if it is a 3 degree alcohol, then this H2O is gone and alkene is obtained. Dehydration is obtained. Okay. Oxidation of catalytic dehydrogenation, removal of hydrogen. So if it is a 1 degree alcohol, you will have aldehyde. If it is a 2 degree alcohol, you have ketone. If it is a 3 degree alcohol, not oxidation. This metal is doing nothing. Due to high temperature, we are having dehydration. Okay, these metals are of no use in 3 degree alcohol. It is the high temperature which is causing dehydration. Absolutely clear. Very important point. I want to add one more in case of manganese. Here we did 1 degree, 2 degree, 3 degree alcohols. Manganese only if I have MnO2. Okay, MnO2 is very specific for oxidation. It oxidizes only allylic or benzylic OH to carbonyl. Okay, only these. So, for example, if I have CH2 double bond CH single bond CH2OH and I am given MnO2. So, you will just go to this stage. If I am given, say, let us see, this is OH and this is OH, and now MnO2 is given. So, you will oxidize only benzylic and leave the other OH, which is non-benzylic, non-allylic in the molecule as such. Is that absolutely clear? MnO2 is a very, very specific oxidizing agent. Okay? Catalytic hydrogenation we have done. And then we have POC of alcohols. Very important. Very, very important. Practical organic chemistry of alcohol. You should always read along with NCERT lab manual. I will refer lab manual today. Don't worry. If you don't have, don't worry. I will share the screen. Okay. POC of alcohols. First, of course, acidic nature, but they are not sufficiently enough acidic to give us the litmus test. If we think that they will give the litmus test, answer is no. They will not give the litmus test. Acidic nature, alcohols are amphoteric. They are weaker acids than water. So do not react with NaH. Okay. They are amphoteric. They are weaker acids than water. So do not react with NaOH. They do not give litmus test. Okay. Coming to steric ammonium nitrate, can, yes, ammonium. The formula for steric ammonium nitrate is NH42CeNO3 whole 6. Now see how bright, beautiful orange color can is originally. Okay, it is like this. And when we dissolve it, then we get this red complex or red color solution where cerium NO3 4, here NO3 6, NO3 4, and alcohol itself is acting as a ligand 3 and ammonium nitrate separate. We are interested in this. It is a single electron strong oxidizing agent. What? CAN is a very, very important oxidizing agent. And in the process itself is converted to cerium 3 plus from cerium 4 plus because it will be reduced. Na? So from cerium 4 plus, it is reduced to cerium 3 plus. Is that clear? With phenols, we get dark red or brown color. And for alcohols, we get red complex or red color solution. See? Yeah, and this solution here, I'm not doing any such change for this alcohol. Na? So even 3 degree alcohols will give this. Phenols are giving as a dark red or brown color, but still giving some test. Na? So steric ammonium nitrate test is important, given by all alcohols. Then comes the Lucas reagent test. Lucas reagent is concentrated HCl plus ZnCl2 anhydrous. Alcohols are soluble in this reagent. Now see, reagent is HCl and ZnCl2. We are not having any water. Okay, conditions are anhydrous. Clearly written that it is anhydrous. So you don't have any water. ZnCl2 is present in concentrated HCl and now you are adding alcohol to it. So when I add alcohol to this reagent, it is soluble. So you will not have any separation of crystal or any precipitate. So alcohols are soluble in this reagent. But as the reaction proceeds, alcohol will react with HCl and RCl is formed. So that formation as it appears, as it formed, RCl formed is sparingly soluble in this reagent. It is not soluble. Okay. So by the time frame in which that white precipitate appears, we have planned the test. So if I have a 3-degree alcohol and Lucas reagent is added, I will have immediate turbidity, very fast. You just add the alcohol, you will get the turbidity. If it is a 2-degree alcohol, as the rate of reaction goes down, so yes, some time it will be there. After 5-10 minutes, you can get turbidity. But if you have a 1-degree alcohol, okay, no turbidity in cold, only turbidity appears after boiling. But remember, I'm not generalizing this whole thing for always. What I want to say is a 2-degree alcohol or a 1-degree alcohol, when goes by this, so entirely we are talking of SN2, right? It is much slower as a process and reaction is taking place gradually and all those things. So we are saying, but what if I have a 1-degree alcohol which is say CH2OH? I will have a very fast turbidity for these one. So this is not a hard and fast rule. All 1-degree alcohols will give turbidity only after boiling. No, we don't know. And in chemistry in general also, there is no such statement like always this will happen. Because the structure to structure, the properties may vary. The basics we'll remember that what is the basic? That with Lucas reagent, we want to form a SN1 reaction preferably. And if not possible, fine, we'll go for SN2 also, okay, whatever is required. And the faster that reaction is, faster will be the formation of RCl. And we'll say, okay, the reaction is giving us this turbidity, fine. Is that okay? So no turbidity in cold, turbidity appears only after boiling. 2-degree alcohol, turbidity after 5 to 10 minutes. Is that absolutely fine? Right? So there is nothing like always for any of these, right? Coming to this, reaction of Grignard reagent with very basic question. Basic question, but what is the point I want to tell? Reaction of Grignard reagent with C8H8O followed by hydrolysis gives compound A which reacts instantly with Lucas reagent. It is clear that it is reacting instantly. So anyhow, I have to have something which is very stable, carbocation. Okay. And the compound B is. Now, the B is after Lucas. So we need something which is before Lucas, which is alcohol. So wherever they are suggesting Cl, I will put OH. See, this if it is. So I'll say, okay, the parent alcohol could have been this. Here, I will say this. Now see, these are 1-degree alcohols if I go by that logic. Whereas it says instantly, this is not justifiable. Coming to this is also not justifiable. This is, yes, true, because if I had OH here, it is 3-degree and all good. Now I have to check, can this be formed by the possibility that if I have a Grignard of C2H5, then it says C8H8O. So this is C8H8O. Right? So we have to check what are the alcohols. Then out of these, we eliminate the options which are not in sync with our information given. And then you zero in 1 or 2 possibilities of the question. And from there, you select the best possible option. Is that absolutely okay? Clear? So this is how you will do the questions. Victor Mayer test. Yes. Victor Mayer test is also known as RBC test. As it is not given in the NCERT, you will depend totally on these notes. Okay. It is also used to separate different degrees of alcohols. I would rather use not separate, to identify. Separate though, we should have some sort of changes should be there. Okay. Some sort of variations at 1 degree can be precipitated out or can be distilled off. Then only I can use the word separate, or else I will just use the word identify. Red phosphorus. So what is the sequence of reagents? First is red phosphorus I2, which is basically last week SN2. PI3 will be formed. You will have iodo alkane. Then AgONO, again last week. That if you use silver nitrite, you will have nitro. Now this nitroalkanes will have tautomerization, right? And I will have this nitrosooximino. And if you remember the tautomerism week, I told you that this is a special case in which oxime is found to be stable over nitro. And so oxime is formed. And NNO2HCl is the third reagent. NNO2HCl is fixed NO plus reagent. Attack. Now I have got this again, this nitroso group came and I have a center which will be active methylene like this. So it is in a tautomerization, which ultimately is having acidic H. Whether I take H from here or take H from here, nitrolic acid is obtained, which is blue in color. You add NaOH, that blue color changes to red. So for 1 degree alcohol, we got red. RBC is red, blue, colorless. Okay, so for 1 degree, we got red, 1 degree, 2 degree ke liye blue, and 3 degree we'll get colorless. That is what we want to say. Okay, so moving further, so this was 1 degree alcohol, but same sequence, first red phosphorus HI, then AgNO2. So till there I got nitroalkane. I also got oxime, but now my oxime, once attacked, I don't have that acidic H. So here I got nitrolic acid, as that acidic H was available. So I was referring it to as an acid, where here I'm not having that acidic H. So there is no tautomerization, no acidic H, no tautomerization. So even if I add NaOH, okay, even if I have NaOH, blue color continues because salt is not formed. Blue color continues as salt is not formed. So 2 degree alcohol is giving you blue color. 3 degree alcohol, after nitro formation, there is no possibility of tautomerization, no possibility of any such acid form. So it remained colorless from the start itself. So 1 degree alcohol red, 2 degree alcohol blue, 3 degree alcohol got colorless solution. Is that absolutely okay? Then there is idoform test for alcohols. Of course, not all alcohols will give this test, but ethanol and 2 degree methyl alcohols will give this test. NH plus I2 or NaI you can take. And this is how idoform is formed. Ethanol and all secondary methyl alcohol give this test. NaOH plus I2. So this is, I have written the mechanism if you want to use, that how NaOH plus I2 converted to NaOI and oxidizes our alcohol to aldehyde. Then alpha halogenation of this aldehyde, that CH3 has become CI3. CI3CHO. Then OH minus attacks, pi open, pi close, and CI3 being good leaving group is removed. This is our yellow precipitate, which we are saying for idoform test. So it is also a test for particular types of alcohols. Hex 4 in 2-all on treatment with PCC gives A. A on reaction with sodium hypoiodide. See, this sodium hypoiodide is idoform. Hex 4 in 2-all. PCC, and then hypoiodide oxidation like this. Okay. A on reaction with sodium hypoiodide gives B. So we got this as a B, which on further heating with soda lime gives C. So we'll remove this. And we got butene. The compound C is butene. Clear? Coming to reactions of polyhydric alcohols. Very, very important. Reaction with HI. Remember this. Take the screenshot of this page. Vicinal iodides are unstable. Gem dihalides are not unstable. Okay, you can form iodoform, but you cannot form this type of vicinal triiodo situation. That we cannot form. Is that clear? So CH2OH, CH2OH is forming CH2I, CH2I. Vicinal are unstable, so you will remove them. Alkene is formed. Further add HI, iodoalkane is formed. So how many moles of HI we have consumed? See 2 to here and 1 after alkene formation. So total from here to here we have consumed 3 moles of HI. Okay, we have consumed 3 moles of HI. If we have glycerol, 3 moles of HI will just form triiodo. Again, it is unstable, so allyl iodide is formed. If they given a question like glycerol with limiting HI, what will be the product? You give answer as allyl iodide. But if excess of HI is given, then further addition will start. Again, I2 is gone. Again, HI is added. And we ultimately have isopropyl iodide as product. Now, don't limit yourself only to this, like glycerol and glycol. It could be to any compound. Okay. I want to say like pH, CH, OH, CH, OH, CH, OH, CH2, CH3, anything like this is given. Anything from a cycle is given. Something like this is given. You got my point? So, as a limit, this is the benchmark that in glycerol you will have this reaction. With PI3, I will have iodo introduction, I will have ethene formation, but after alkene, I don't have that electrophilic addition possibility. So, answer will stop at ethene. And with glycerol, answer will stop at allyl iodide. We cannot have further addition of HI. ठीक? Pinnacle-pinnacolone rearrangement. Very, very important reaction. Very, very important reaction. Okay. Let us see what is given in this. Now in pinnacle-pinnacolone, it is first of all, remember it is an intramolecular rearrangement. It never goes here and there. Okay. So as I told, pinnacle is this. When I treat it with concentrated H2SO4, when I treat it with concentrated H2SO4, protonation of OH took place. Water removed, methyl came. MEC double bond O, CMA3 is there. H plus is gone, pinnacolone is formed. Okay. With KHSO4, glycerol gives acrolein. With KHSO4, glycerol gives acrolein. Right? This is the method. Take it like H2SO4 only. Treat it like H2SO4. We got this and then dehydration and acrolein is formed. Very important point here. Acrolein has a smell of hot oil while cooking. That type of smell you can form for acrolein. Absolutely clear? Ester formation. Alcohols will form ester. All alcohols can form ester in fact. So esterification reaction. But if I talk of polyhydric, remember 1 degree alcohols will form ester faster than 2 degree alcohols. Rate of esterification more acidic because when you form ester, you remove these H and you remove these OH. So 1 degree alcohol, then comes the 2 degree alcohol, and then comes the 3 degree alcohol. That type ester is formed. With HNO3, nitroglycerin is formed. Not HNO3, this is not a nitro, this is ester, acid HNO3 with alcohol, removing water, and we have nitroglyceryl trinitrate. It is an ester. This is an ester. It is not a nitro compound. Highly explosive dynamite. This glyceryl nitrate is explosive called dynamite. Is poisonous, colorless, oily liquid, insoluble in water. It is shock sensitive and is called dynamite. Yeah. Oxidative fission with HiO4. If I do oxidation with HiO4, go for shorthand. No need to have the entire mechanism. Vicinal OH has to be there. If a molecule has more than one OH, but the location is far away, then this is not valid. So it has to be vicinal. So you just put break, both side you add OH. And for such one break, you need one HiO4. HCH, OH is formed, remove water, formaldehyde is there. Take, see, 3, you do 3 break. Each side you break and each side you take one HiO4. So OH, OH. Now you can see the center has 3 OH. Removing water, you have formic acid. And the consumption of HiO4 is 2 moles. Come here. I wrote gadda. That is pothole. Be careful. OH, yes, 1 HiO4. But this OH is no more vicinal. So don't consider this. This will continue as such. Clear? Alpha hydroxy ketones could be there for HiO4 fission. Alpha hydroxy ketones, same way you do. OH, you add acid and aldehyde. Alpha NH2 positions also you will get. If a molecule has OH and NH, NH is gone. So ketone. Take alpha OH and Cl is there. Then that is also formed to ketone. That is a fixed thing. Alpha diketo acid. Remember, HiO4 fails for alpha keto carboxylic acid and alpha hydroxy carboxylic acid. That is a special point to remember, that HiO4 fails for these, though its alternative called lead acetate, lead tetraacetate, that is successful for this also, but is also successful on alpha hydroxy acid and alpha keto acid. Same thing, you just break and add OH. That is all you have to do for them. Okay, so that brings us to the closure of alcohol part. First, is there any problem? Raise your hand if anyone has any problem. Yes, I have got one. Yes, tell.
What is the difference in the function of hot and cold NaOH?
NaOH, or what did you say? NaOH bole to sodium hydroxide?
Yes, ma'am. Hot NaOH and cold NaOH.
Ideally, in which chapter? Because this question is more relevant when it comes to aldehyde ketone, not here.
Okay, it was one of the questions I came across.
Was it on aldehyde ketone? Like basically, in both you will take aldol. Okay.
Okay,
That is first
yes.
thing. But if it is hot NaOH or like above 5 degree, 10 degree centigrade, then you do the dehydration in aldol. You report
And if
unsaturated product. And
and
if
if
it
we have
is cold, then you report OH, the beta OH carbonyl.
okay, ma'am. So,
So
but the
there,
acids can react with both.
what can react with both?
When we have to check which acids will react and esters.
No. I didn't ask for acid or ester. I said aldehyde ketone mein
Yes, ma'am.
aldol
That
condensate.
aldol. Okay, that
हाँ,
is fine. But then the question was
that is
like,
one thing. And if I talk simply for carboxylic acid, so whether it is cold or hot, always they will react.
okay,
Okay.
ma'am.
Phenols, they will react.
And ma'am,
Right.
in
Alcohols, they
the
will not react.
right, ma'am. Ma'am, in the rate of esterification for
Yes.
alcohol,
Huh?
where does the position of like allylic and benzylic alcohol stand?
They are faster ones
Okay,
because the nature we are using is their acidic nature. So they are faster to react than our usual other alcohols, 1 degree, 2 degrees.
okay, ma'am. Thank you.
Ma'am, could you explain the NH2 and OH part in the slide?
We will repeat which part?
NH2 and OH, the HiO4 addition.
HI for oxidation.
Yes, ma'am.
I didn't go for the mechanism. I went only that whatever you get, it is vicinal diol or NH2OH or double bond O, double bond O. Okay, the fixed thing you follow is you identify where it work.
Yes, ma'am.
Okay, then you break this bond, and when you break, iska one valency will open, put that OH here, and iska one valency open, put OH. Once you put OH, you write them that okay, COOH stable, report as such. CHOH unstable, so you will dehydrate and report it as aldehyde.
Okay, ma'am.
That is a fixed pattern you will follow. Is that clear, everyone?
Yes, ma'am.
Okay. Anyone else for doubt? Please tell. Yes, Raghav. Yeah. Tell.
Ma'am, can phenol show positive steric ammonium nitrate test?
Phenol shows steric ammonium nitrate, but let us check the lab manual once what it has written. No, but yes, it can show.
Ma'am, in a question assignment, we had like
Hmm?
we had to tell whether it shows positive steric ammonium nitrate test, and they gave it shows only for 3-degree alcohol, but not for phenols.
And only for 3 degree or for all alcohols?
Like we had like 3-degree alcohol and like 1-degree alcohol that's
Others were
conjugated
only
and
phenol. Others were
huh?
only phenols. Others were only phenols, not any other like.
Ma'am, we didn't have 1-degree and 2-degree in the options.
That is what I was asking. Others were not there.
No,
Let
ma'am.
me read from NCRT, beta. Or I should share the screen. Okay, so we will together see what they are. How to share a screen? Screen here and then. See, can you see the NCRT lab manual?
Yes.
Yes. So steric ammonium nitrate, let me go. This is the procedure, but where the theory is given, Lucas test theory is given. Let us read here. Alcoholic compounds on reaction with steric ammonium nitrate gives a red color due to the formation of this complex. Distinction between primary, secondary, and tertiary alcohol can be done on the basis of iodoform. Okay, potassium, this. Okay, they have not referred here specifically about phenols, right? Alcoholic group. Let us go
Yes.
to further. The red color disappears after keeping the reaction mixture for some time. The color also disappears if exchange of steric ammonium nitrate solution is added. Excess. Therefore, use of excess of steric ammonium nitrate solution should be avoided. Okay, fine. Iodoform. See, iodoform is this week in alcohols, huh? This
Yes.
is given in lab manual. Let us go further. Lucas reagent. No. Phenolic group. In phenolic group, what all tests they are giving? They are not giving steric ammonium nitrate. Though it gives, but lab manual is not referring, so then avoid. Or I will give you a much clearer answer with other lab manual references also, that what is taught in usual 12th. Because see, they are giving Thalin test, they take this FeCl3 test. Okay, moving further. Nothing. Ferric, Thalin test. Okay, that is it. That is why they are not taking probably if they have gone through with this depth. Otherwise, if we are asked in general, then it gives. So here is some more regarding pinacolone rearrangement. We have done there somewhat, and some more things let me add. So as we were saying that net reaction is carbocation formation, then rearrangement and formation of ketone like this. And it is completely reversible. So backward reaction is also possible, and that is called retropinacol. Okay, reverse reaction is called retropinacol. Now, see the examples. We discussed that it is an intramolecular rearrangement that we discussed. How to proceed? When you have the two OH defined in the product, identify the stable site of carbocation. Okay, I had two sites, methyl, ethyl. So I'll prefer the methyl site because the carbocation here is more hyperconjugated. And then we'll have a shift of ethyl and the product. If you would have formed the ethyl side carbocation, it is wrong. So what is the basic key? Identify where you will form a carbocation, and then you will see what will rearrange. See here, both side I was having the same carbocation. Now what will rearrange, ethyl or methyl? So ethyl will rearrange. Okay, so ethyl is rearranging. So this is formed. ठीक, NNO2 plus HCl, NH2, NO plus is formed. Again, formed carbocation, OH, same thing, shifting. Cl and AgNO3 given, you can form a carbocation. So anyhow, if there is a possibility of OH से adjacent site, this alpha, then beta site पे carbocation formation, then you will have such rearrangement. Okay. See, for H2SO4, we have seen where we will form methyl side, which will migrate H and ET, H will migrate. So this is how you will have answer. But if it is a reaction with first TSCl, now see TSCl के साथ जो reaction है, ये reaction एसिड्स से एसिड डेरिवेटिव बनने वाली रिएक्शन है. मतलब ये TSCl अल्कोहल के साथ इस तरह से एस्टर बनाएगा. सो H2SO4 मोर सब्स्टिट्यूटेड पे कार्बोकेटायन बना रहा है, इसलिए आंसर वैसा है. बट TSCl में लेस सब्स्टिट्यूटेड से रिएक्शन होगी क्योंकि लेस स्टेरिकली हिंडर्ड पार्टिसिपेट करता है. ये डिफरेंस है दोनों में. सो प्रोडक्ट्स विल बी डिफरेंट. अब ये बना और फिर ये हटा, तो यू विल हैव अ डिफरेंट प्रोडक्ट फ्रॉम व्हाट यू आर गेटिंग हियर. हियर EtCO था, यहाँ MeCO है. ठीक. It is also for cycles. Yes.
Excuse me, ma'am.
This type.
वो,
And what is the driving force? Complete octet. Last week में हमने पॉइंट डिस्कस किया था कि कार्बोकेटायन का ऑक्टेट अगर पूरा है तो वो एक्सेप्शनल स्टेबिलिटी दिखाएगा, है ना, कंप्लीट ऑक्टेट. सो ये यहाँ ये जो कंप्लीट ऑक्टेट वाला कार्बोकेटायन है, दैट इज व्हाई इट इज बिकमिंग सो वेरी स्टेबल. इज दैट क्लियर? ठीक है. And this is how it proceeds. See again, which is more stable? This side, the pH side is more stable. And then this shifts. Unstable carbocation. ये बनाते तो unstable. So this is the answer. In epoxides you can have, right? If you have a suitable situation, AlCl3 plus is formed. See this one. Even ring contraction can take place in pinecolone, because the complete octet carbocation is so very stable. So that is why that is also possible that ring contraction can take place. Is that clear? Both cases. Moving further, this is retropinecol. Just
Ma'am, the ninth one.
Reverse of pinecol is retropinecol. I have allowed all of you to unmute yourself in case if you want to ask doubts. Still, I'll prefer अगर आप पहले हाथ खड़ा कर दें, if you just raise your hand, it would be easy for me. Yes, someone is asking for doubt, है ना? It is easy. Otherwise, I will be disturbed multiple times. Yes, Ekansh.
Ma'am, the ninth example.
एक सेकेंड एकांश, मेरा स्पीकर बंद हो गया. मैं बताती हूँ जब बोलना. अब बोल.
Ma'am, ninth example.
Ninth example. हाँ बोल.
Ma'am,
जैसे
वहाँ पर
AlCl3. हाँ,
हाँ, हाइड्रोजन क्यों नहीं शिफ्ट हुआ?
हाइड्रोजन यहाँ पर हाइड्रोजन भी शिफ्ट हो सकता है. बेसिकली अगर तुझे याद हो तो माइग्रेटरी एप्टीट्यूड में अपनी बात हुई थी कि H और pH का माइग्रेशन बहुत क्लोज है. यूजुअली फॉर JEE हम H को प्रिफर करते हैं, बट देयर आर रिएक्शंस जहाँ पर कई बार हमें pH ऊपर मिल सकता है. ये इसी तरह की एक रिएक्शन है.
तो ये बस एक केस मानना है.
हाँ हाँ, और ये JEE में आएगा नहीं इपॉक्साइड वाला. ये वाला स्पेशल केस हो गया ना, बाकी जगह से टकरा रहा है तो ये नहीं आएगा अपने लिए. ठीक है.
Yeah.
फिर आई हैव प्रजिन.
मैम वो एक TSCl में एक डाउट था, TSCl का.
हाँ,
कैसे?
एक सेकेंड. TSCl वाला इससे भी पीछे है मेरे ख्याल से. हाँ, यहाँ है.
एग्जैक्टली पिनोकुलोन से रिलेटेड डाउट नहीं है, बट मैम TSCl लाइक OH के साथ अच्छा रिएक्ट करेगा कि SH के साथ? मतलब एक क्वेश्चन में दोनों भी दिया है और TSCl दिया है, तो क्या प्रेफर करेंगे?
लेट मी थिंक, THCl है तो SOOH है, और अटैक में होता क्या है? अटैक हमारा क्या है? ROH और THCl। ये क्या है यहाँ पर? SOO और Cl। तो हम ये चाह रहे हैं इसका अटैक इस पर एज अ न्यूक्लियोफाइल, है ना? Rajin, is it sulfur which should be reacting fast क्योंकि इसका अटैक एज अ न्यूक्लियोफाइल होता है?
हाँ मैम मेरे को आंसर एग्जैक्टली नहीं आते हैं, बट ठीक है मैम।
मतलब सल्फ ऑक्सीजन पुअरर न्यूक्लियोफाइल होगा देन सल्फर,
अच्छा
तो
ओके मैम,
इसलिए, और ये अटैक न्यूक्लियोफिलिक होता है इसलिए, है ना?
ठीक है।
ठीक, चलो तो मूविंग फॉरवर्ड, तो ये हमारा पिनेकोलोन हम डिस्कस कर रहे थे। अभी एक और चीज बतानी है। सो हम यहाँ आते पहले रेट्रोपिनेकॉल, मतलब बैक जा रहे हैं हम पिनेकोल में। अब ऐसे जब स्ट्रक्चर आए ना, तो जैसे अभी अपन ने शाम को थोड़ी देर पहले बात करी थी कि आप ऑल पॉसिबल कार्बोकेटायन बना लीजिए और देन यू कंपेयर। सो इफ आई सी कि मैं कार्बोनिल को प्रोटोनेट करूं, राइट, तो आई विल गेट दिस टाइप ऑफ कार्बोकेटायन विच इज अगेन रेजोनेटिंग एंड कंप्लीट ऑक्टेट भी उसमें एक पॉसिबिलिटी आ रही है। इफ आई फॉर्म अ डबल बॉन्ड से कोई कार्बोकेटायन, तो डेफिनेटली यहाँ तो बना नहीं सकती, और अगर मैं यहाँ बनाती हूँ तो ये भी अनस्टेबल ही बन रहा है ना? सो अगेन बनाएंगे हम सारे कार्बोकेटायन, और फिर जो हमारा स्टेबल कार्बोकेटायन है उसको हम जैसे आगे बढ़ेंगे तो सी दिस इज कॉल्ड डाइनोन फिनॉल रीअरेंजमेंट। बेसिकली इट इज अ रेट्रोपिनेकॉल। इज दैट क्लियर? ठीक, द डाइनोन फिनॉल रीअरेंजमेंट एग्जांपल ऑफ रेट्रोपिनेकॉल। क्या ये क्लियर है? ठीक, इंपॉर्टेंट केस रिलेटेड टू स्टीरियो ऑफ पिनेकोलोन, और ये बात खास तौर से साइकिल्स पर ही एप्लीकेबल है। ओके, अपन ने ये तो देखा ही है कि व्हेनेवर ग्रुप शिफ्ट्स, इट शिफ्ट्स फ्रॉम द अपोजिट साइड ऑफ द लिविंग ग्रुप, है ना? ये यहाँ से मूव करेगा। अब देखो ये पर्टिकुलर केस है, इसे कई बार सेमी पिनेकोल रीअरेंजमेंट भी बोलते हैं बिकॉज बोथ आर नॉट OH, दैट इज वाई। तो NaNO2HCl लिया हमने, डेफिनेटली ये कार्बोकेटायन बनाएगा। अब ध्यान से देखो, लीविंग ग्रुप है आपका एक्सियल पर, ओके, और उसके अपोजिट साइड से इट इज नॉट दैट इट फॉर्म्स अ कंप्लीट कार्बोकेटायन, एज एन एज इट मूव्स द शिफ्ट स्टार्ट्स। So whatever is opposite that will start. So H is shifting, N2 is going, H is shifting. Okay, so you got a cyclohexanone. ठीक है, आपको साइक्लोहेक्सेनोन इस तरह से मिला। ठीक, so this is when the group which is opposite NT has to shift, right? Wait, Geeteshwar, I'll let you ask after some time. Now see the relative cases. In first one, NH2 and H were NT. Okay, so you had NT position H available. Whatever NT will shift, that is the important part. See here, oxygen is NT, OH is NT. So what will happen? Oxygen lone pair will attack and you will have answer as epoxide. That is the difference. Okay, so there were two cases, NH2 to be maintained on axial. And you can ask me, what if it flips? So that is why to log that flipping, I placed this third butyl on equatorial position. Okay, third butyl on equatorial positions is there. So this cannot flip now here and there, right? This is axial. This is axial. Now it cannot flip because if it will flip, this will go to axial. That is not allowed. Okay. Now see, if NH2 is on equatorial, again I will have two cases. Na? NH2 on equatorial, OH on equatorial, or OH on axial. So again I have two cases. But if NH2 is on equatorial, anyhow, the best group which will be exactly opposite to it or anti position is the ring itself. Okay, the ring, the blue mark, ring itself. So when ring comes, you will have a ring contraction. And it is for both NH2 and OH, whether at axial equatorial or di-equatorial position, you will have a ring contraction like this. Is that clear? ठीक, हाँ गीतेश्वर, now you tell.
Hello.
Hitesh, bol.
Yes, ma'am. Ma'am, the flipping part was made out like if can ring flipping happen and that
No,
reaction,
no,
that part
I
right.
think it is now addressed, na, because
Ah,
I have logged it
yes,
with
ma'am.
right. Okay. So first doubt was with this pinacolone. I think now that is resolved. Let me check my WhatsApp and see the next was the fries rearrangement from uh, that. Why you are putting benzylic rearrangement now? That is an aldehyde ketone, na? Benzylic acid. Okay, first let me go to Fry's rearrangement was asked. So Fry's rearrangement should be somewhere in phenols, and it should be in formation preparation of phenol, na? Intermolecular. I think we are at Fry's. What a coincidence. So Fry's rearrangement first is not in JEE syllabus. Last time also I told you that you can get a brochure from JEE advanced sites. But anyhow, past syllabus also you can get. So Fry's rearrangement, it is phenyl esters under suitable conditions on heating get converted to ortho and para hydroxyketones. So phenyl ester, this could be any group. We are not bothered about it. Okay, phenolic esters are this. RCO, PH, PHO, COR, and hydrous AlCl3 ke sath when we are heating. So basically it is like Friedel-Crafts. This RCO plus is released and it rearranges to ortho and para. Ortho and para acyl phenols. That is Fry's rearrangement. Now it shows KCTC effect. That is a problem basically. That is why the people get confused. And this is the confusing part. At low temperatures, 60 degree or less, para products are favored. It means here para is the kinetic product and ortho is the thermodynamic. That opposite hona is a problem. Usually we always say that this ortho is a KC and para is TC. Okay, this is like a rare case where we are saying ki TC is the ortho one. But in both the cases, yield of phenolic ketone is better than that obtained in Friedel-Crafts reaction. Okay? Because there are no such adduct formation through oxygen and losing the entire reaction. Right? Even if I go, this oxygen is not acquiring positive charge the way it does in phenol. So the yield reactivity is better, so yield is better. So ortho and para phenolic ketones are obtained. Both inter and intramolecular mechanisms have been confirmed. Both inter and intra. So you will have cross. See, here I have so MECO plus and this ring. So I will have MECO plus released and have product on this ring also and on this here also. More activated site, it will be orthopara. So you will have all the products obtained. That is the evidence for that the reaction is inter as well as intra. Both things are possible. Intermolecular concerted like this. Intramolecular concerted. Okay, so that was about Fry's rearrangement. Then comes benzylic acid. That is next week, I guess. Benzyl is PHCO, COPH. That is not this week. Liberman nitroso test. Okay, so Liberman nitroso test is for test of phenols. Liberman nitroso test is test of phenols. Let me see. There is Liberman nitroso test. This. If you want to write, you can write. See, phenol with NNO2 plus HCl NO plus. Then ethanol, then NaOH. Then blue color solution is formed. Okay. Now, on the way, there was red, and which is finally converted to blue. So let us see. First, phenol, NO plus, para-nitrosophenol is formed, and it can para-tautomerize to monooxime of quinone. Okay, this is a green brown solid. Military green color hota hai iska. Again, as conditions are H plus, we'll have protonation, N plus, phenol, next molecule of phenol is attacking at this nitrogen. So you get a di-type structure which is called indigo phenol. It is red. And when we add NaOH, then this O minus is forming a salt and then it is a blue solution. So you people please write. I will wait for you.
Ma'am, can you explain the after green brown solid part?
After green brown solid formed, see phenol के para position पे there can be attack of this carbocation ना. This NOH protonate होगा तो H2O हटेगा, and that plus is attacked by para position. ES on phenol, so it is red, and salt of this is blue. This is Claisen rearrangement. See, allyl phenyl ethers. Okay, this is the allyl part. This is the allyl part. Allyl phenyl ethers when heated to 200 degrees centigrade. Okay, we don't need any other reagent. Just heating itself is sufficient. So we heat it to 200 degrees centigrade and it converts to orthoallyl phenol. Orthoallyl phenol. And if I could have a star marking, say if this is the corner carbon I mark with this, then it comes here. Okay, orthoallyl phenol. It is an intramolecular rearrangement of phenylallyl ether. Now this is intramolecular. The fries we did was intermolecular. To orthoallyl phenol on heating. If ortho positions are blocked, then paraallyl phenol will be formed. Let me explain how. So first, it is a pyrolytic reaction. You don't need any other reagent or anything. It is pericyclic, that it proceeds through cyclic intermediate and concerted. It is intramolecular. See how it is. This C minus CH2 and concerted. And in concerted, we have discussed that there is a alternate bond breakage and formation, like this. So 6-member cyclic transition state is formed. When this is complete, bond formation is formed, breakage is done, like that if it is complete, then this is formed. Double bond O, HCH2, CH double bond CH2, and then you do the tautomerization and you get a phenol. Now here the tautomerization, there is a driving force that the product is becoming aromatic. So you will have this type of thing. If it is not aromatic, then you will not have. If both the ortho positions are blocked, then you cannot have tautomerization and you will lose the aromaticity. But aromaticity cannot be lost, na? So it is jumping again to para position. But para is jumped only when ortho is blocked. If ortho is available, you will end the case with ortho answer. You will not go any further. As it is both side blocked, so we are again using the same thing. Check the arrows. Okay. So 6-member transition state and whatever the process. If again we have this marking, when it comes to ortho, it somersaults and it come inside. When it again goes to para, see the somersault and then again goes to outside. Right? CH2 is now outside. And then there is a paratautomerism. So now it is over. Okay. See here, ortho is blocked and we have a mixture of these two. Right? Here ortho is blocked, here ethyl and mixture. So this star will remain at ethyl valley ring. It will not jump here, ethyl valley ring. And the 2 methyl blocked will have non-mark allyl. Clear? That is how it is. If both ortho blocked and at para position, also one allyl is there and here also one ortho allyl, allyl is there. So it definitely it will start, but para also there is a blockage. And now these both are equivalent. Either could go up. Right? So you will have a mixture of OCH2, CH2, CH double bond CH2 original, or it could be the carbon 14 which went up. Okay, or it could be the carbon 14 which went up. So we'll have a mixture of these two allyl. Right? Now, as I said, the aromaticity is the driving force for it to become enol. Now, if the thing is not becoming aromatic, see, if it is vinyl allyl ether, so basically it is vinyl allyl ether like this. Okay, vinyl allyl. So now when This has the same process. Just that ring नहीं है extra, बाकी तो वही है ना, पीछे ring ही तो नहीं है, बाकी ये system तो वही है. So you will have a 6-member TS, and then when it completes, now there is no tautomerization. This position, this remain as such. So you will have aldehyde ketone now as an answer, whereas when it was aromatic, you were having tautomerization and it was again becoming phenol. That is the difference. Okay, with this, you will not have any further tautomerization to enol. Correct? That was Claisen rearrangement. Now I see there is a question of esterification, trans-esterification and full esterification. That is again not this week, it was carboxylic acid week. Okay, let me check the syllabus once again if you are asking where is it. अगर तुम्हें लग रहा है कि अभी है तो एक बार सिलेबस चेक कर लेते हैं. Where is the syllabus? I think this is PT1 gone. We are in PT5. अल्कोहल एस्टरिफिकेशन यहाँ कहीं नहीं लिखा है बच्चों. फिनॉल, हाँ एस्टरिफिकेशन उसमें लिखा है, फिनॉल्स में. ओके, अल्कोहल्स में नहीं दिया है. डोंट वरी देन. अल्कोहल्स में तो ये फिनॉल में अगर दिया है तो ये तो शॉर्टन बॉमन वाली रिएक्शन आएगी. शॉर्टन बॉमन वो है ना, फिनॉल प्लस एसिटाइल क्लोराइड, वो सैलिसिलिक एसिड प्लस एसिटाइल क्लोराइड, वैसी वाली रिएक्शन. ठीक है, हाइड्रोलिसिस ऑफ एस्टर्स एंड अमाइड्स इन प्रिपरेशन, दैट फॉर्मेशन ऑफ एस्टर, एवरीथिंग इज इन कार्बोक्सिलिक एसिड. PT6 में है वो. ठीक है, सो एस्टरिफिकेशन इस वीक का नहीं है, परेशान मत हो. That is later syllabus. So let's go further. All test of alcohol, phenol and ethers. Now this is important. All test of alcohol, phenols and ethers. तो सबकी POC चेक कर लेते हैं एक बार, और NCERT का पेज भी चेक कर लेते हैं, दोनों काम कर लेते हैं. So पहली स्टार्ट अल्कोहल्स का तो हमने आज कर ही लिए. There is nothing more to alcohols than what we did test. हमने टेस्ट सारे लिए हैं अल्कोहल्स के. ठीक, बट स्टिल अगर तुम्हें थोड़ा मन में शक हो तो हम अल्कोहल्स को लेकर एक बार और देख लेते हैं. ये प्रैक्टिकल ऑर्गेनिक केमिस्ट्री ऑफ अल्कोहल है. ठीक है, इट इज नॉट वेरी बिग, सो देख ही लेते हैं. लिटमस टेस्ट आता है, सोडियम लिथियम वगैरह के साथ हाइड्रोजन का लिबरेशन, ये देख सकते हैं. NNH2 के साथ अमोनिया का लिबरेशन. ग्रिग्नार्ड है तो ग्रिग्नार्ड के साथ यू विल हैव दिस CH3H, this, and this is ROMGX. This is not a qualitative test. It is a quantitative test for estimating number of alcoholic group in a known compound. Can अपन ने देख ही लिया. 1 degree, 2 degree alcohols, 3 degree alcohols, red color, but no further oxidation. Here there is a possibility of oxidation. Dichromate में yes, 1 degree, 2 degree alcohols, है ना, orange से green. 3 degree alcohol, no change as there is no oxidation. Right? KMNO4 we have done 1 degree, 2 degree alcohol. Mn2 plus colorless में जाएगा. 3 degree is condition dependent, so not written. Lucas test we have discussed in detail today. And these all alcohols will give immediate turbidity. Purpose of ZnCl2, ZnCl2 plus HCl will form H2ZnCl4. So basically generation of H plus. And Lucas test is used to differentiate primary, secondary and tertiary alcohols. Then comes the Victor-Meyer's test. Now talking of Victor-Meyer's test, red, blue and colorless, RBC. It is used to differentiate primary, secondary and tertiary. I think we have done this. Red phosphorus iodine, then AgNO2 comes. Right? After AgNO2 you have a tautomerization. Then NN2 plus HCl. 1 degree alcohol will form blue color nitrolic acid, 2 degree blue color pseudonitrile and 3 degree colorless. Now after these blue color we add NaOH, so 1 degree will form a salt which is of red color. So ultimately we are having a Red color for primary alcohol, no acidic H in 2 degree pseudonitrile, so blue color continued to be blue color, and that 3 degree alcohol, no reaction. Simple esterification if you want to see. It is like alcohol plus carboxylic acid or acid chloride forming ester. Esters are a fruity smell, so this could be used as a test for alcohol or for carboxylic acids. Okay, that was POC of alcohol. Now, if I go to POC of phenol, which is extremely important. So, see, reaction with phthalic anhydride. फिनोफ्थलीन फॉर्मेशन रिएक्शन जो है ये यूज हो रही है. नेट रिएक्शन आप ऐसे याद कर सकते हो कि थैलिक एनहाइड्राइड का ये जो डबल बॉन्ड O है और फिनॉल का पैरा H, H2O is gone. That is basic. White crystalline solid phenolphthalein is formed by this reaction. ये रिएक्शन अगर फंडामेंटली देखो तो EAC है. देखो मैकेनिज्म. थैलिक एनहाइड्राइड पे हमने प्रोटोनेशन कराया. We got this कार्बोकेटायन यहाँ पर. Now it is such a bulky electrophile, so phenol पे अगर ये अटैक करेगा भी तो it will go to para position. फिनॉल की para position, right? ये बना. ठीक, ये सुई एरोमेटिसिटी आ गई फिनॉल की. अब ये कार्बोकेटायन, ये जो एक OH बच गया है यहाँ, ये कितना सही पोजिशन है फॉर फॉर्मेशन टू दिस रिंग, दैट रिंग एंड ऑक्सीजन. हियर इज अ कार्बोकेटायन एंड अगेन फिनॉल की पैरा पोजिशन से अटैक. सो यू हैव दिस स्ट्रक्चर. तो अब ये जो बना है, अगर इसको मैं नेट रिएक्शन ऐसे H2 निकालूं तो भी तो यही बन रहा है. सो दैट इज व्हाई आई टोल्ड यू कि यू कैन प्रोसीड बाय नेट रिएक्शन. Now this is the phenolphthalein pura HPH. When you put NaOH, then OH में से O minus, है ना, O minus गया. So you have a salt. Okay, and this is how it finally exists as a dianion. This is important, huh? This dianion, because this is given in NCERT. So this dianion is red or pink color. That is why when in alkaline medium, phenolphthalein changes from colorless to red or pink color. That is this dianion. See, if I add further OH minus, and if you increase the pH further, okay, around 10.5 tak it shows pink color. If you increase it further, you will have a trianion like this. And this trianion is again colorless. This is the phenolphthalein 1% solution, which is colorless. This is when it is added in the acidic or highly alkaline medium, and this is when it changes color. Clear? Now take screenshot of this.
Ma'am, I had a doubt in the previous.
हाँ बोलो.
Ma'am, after the first phenol gets attached,
हाँ.
and second time protonation happens, why doesn't it happen in the other double bond O, because less steric hindrance?
Because this is the more stable complete carbocation versus this. This is also having double bond O, complete carbocation from here and from this oxygen also.
Oh.
Plus resonance. Okay.
Resonance is there that side also, but.
हाँ, resonance is there, but इतना complete इतने सारे oxygen का complete octet उसको नहीं मिलेगा.
Okay.
So I was telling this. So orthocresol red देता है, metacresol bluish purple देता है, और paracresol no reaction because the para position is blocked, no color. Catechol usually blue color but takes longer time to appear. Resorcinol green fluorescent color of fluorescein. Phenol again colorless. मतलब whenever para position is blocked तो phenolphthalein वाला टेस्ट फेल हो रहा है. ठीक है, और बाकी ये सारे कलर्स जो मैंने यहाँ स्क्रीन पे दिखाए ये सब एनसीईआरटी में से अपन ने कॉपी किए. ठीक है, एनसीईआरटी लैब मैनुअल में दिए हैं. फिर आता है टेस्ट विथ न्यूट्रल FeCl3. So with neutral FeCl3, phenols form colored complex with neutral FeCl3. This is the complex. PHOH or FeCl3 form Fe, PHO 6 times 3 minus. Okay. Now resorcinol ऑर्थो, मेटा एंड पैराक्रिसॉल्स ये वायलेट कलर देते हैं, कैटेकॉल जो है वो ग्रीन कलर देता है, बट 1 and 2 नेफ्थॉल्स कोई भी कलर नहीं दे रहे. अगेन इट इज फ्रॉम एनसीईआरटी, टेक अ स्क्रीनशॉट. न्यूट्रल FeCl3 में ऑर्थो, मेटा, पैराक्रिसॉल्स वायलेट दे रहे हैं, ब्लू दे रहे हैं, कैटेकॉल ग्रीन दे रहे हैं. ओके, but 1 and 2 nephthols and alpha nephthol and beta nephthol do not give any characteristic color. Is that okay? ठीक. Give mechanism for DDT formation. I think same as phenolphthalein you can do. H2SO4 a protonate and again ES on chlorobenzene. सेम प्रोसेस करके, और इसको भी ऐसे नेट याद रखना बेहतर है कि पैरा पोजीशन से ऐसे H लेके हटाया एंड यू विल गेट द स्ट्रक्चर ऑफ DDT. ठीक, चलो और आगे बढ़ते हैं. POC कर रहे थे हम. डायजो कपलिंग ऑफ फिनॉल हो सकता है. तो फिनॉल अंडर माइल्डली अल्कलाइन कंडीशन, डायजोनियम विल अटैक पैरा पोजीशन, and in case of phenol this color obtained is orange. Okay, though it keep on changing of what type of phenol we are using. So phenol में पैरा पे डाइजोनियम कपलिंग हुई, डाई बना, that colored compound is of orange color. Appearance of that color is confirmation of phenol का डाइजो टेस्ट. ठीक, वही टेस्ट अगर आपने अल्फा नेफ्थॉल पे करा तो देखो इन 2 रिंग्स में से इस रिंग पे कोई ग्रुप नहीं है, इस रिंग पे OH है, तो OH की पैरा पोजीशन पर अटैक होगा. We'll have attack on OH की para positions like this. Okay, like this. So ये बना brown color called claret brown. ब्राउन कलर डाई बनती है इसमें. अल्फा नेफ्थॉल में कौन से कलर की डाई बनी है? ब्राउन. ठीक, ये देखो. अब ये होता है बीटा नेफ्थॉल. लैब में ये ऐसे ही दिखता है, ब्राउन टुकड़े टुकड़े, ऐसा लगता है जैसे स्टोन की लेयर्स किसी ने कर दी. So, अगर आपने बीटा नेफ्थॉल पे सेम चीज ली, अब अगेन दिस रिंग इज मोर एक्टिवेटेड एंड प्रिफर्ड पोजीशन ऑफ नेफ्थलीन का अटैक क्या होता है? ऑर्थो, सॉरी अल्फा, विच इज ऑल्सो ऑर्थो टू OH. तो यहां से बनता है बीटा नेफ्थॉल का अटैक. ओके, और उसमें इस तरह का डाई बनती है, रोजी रेड डाई. ये देखो याद रखने का तरीका, बिपाशा रॉय, बिपाशा रॉय. ठीक, इट इज बीटा नेफ्थॉल में रेड, फिनॉल में ऑरेंज, एनिलीन में येलो. ठीक है, बीटा नेफ्थॉल रेड, फिनॉल में ऑरेंज एंड एनिलीन में ऐसी येलो डाई बनती है. ये इज दैट क्लियर? ठीक, सो ये डाई टेस्ट हो गया. दिस इज सेम थिंग. लिबरमिन नाइट्रोसो टेस्ट अभी हमने लिखा ही है ना. PSC ऑफ फिनॉल, हाँ, एसिडिक नेचर, इट विल गिव this acid turns blue litmus red. So phenol is sufficiently acidic to turn blue litmus red. जब हम solubility की बात करते हैं तो solubility in NaOH and in Na2CO3. So phenol is soluble in NaOH and Na2CO3 but is insoluble in NaHCO3. NaHCO3 में नहीं घुलता. And thus this reaction can be used for such questions. How will you separate them? जैसे मिक्सचर है मेरे पास, उसमें मैंने NaOH डाला, तो देखो ये 3 में से आउट ऑफ दीज 3, फिनॉल, टॉलिन एंड एनिलीन, ओनली फिनॉल विल गो इनटू द एक्वस लेयर ना, क्योंकि NaOH से वही रिएक्ट करेगा. एनिलीन एंड टॉलिन कंटिन्यूड इन ऑर्गेनिक लेयर. अब क्या क्या है ऑर्गेनिक लेयर में? टॉलिन एंड एनिलीन. नाउ वी पुट HCl. Aniline will react. PHNH2 will go into aqueous layer and toluene remains in organic layer. Clear? ठीक. हाँ गीतेश्वर बोलो.
Ma'am, in this case, with like solubility in NaOH, Na2CO3 and NaHCO3, is there like a general order for 1 degree, 2 degree, 3 degree alcohols and like acidic hydrogen, something like that?
No, it is a simple thing that whichever is more acidic in terms of strong acid displaces weak acid is the key. There is no such order. Like Na2CO3, you should know the second dissociation constant of H2CO3. Okay, so anything that is having a Ka greater than that will give this reaction. For NHCO3 displacement, our acid which we want to check should have a Ka greater than first dissociation constant of H2CO3. That is the key. There is no such order. Okay. So we were doing organic layer, so this is separated. Now, if we are asked phenol and benzoic acid to separate, so here I can use NHCO3 because phenol will not go into NHCO3 and acid will go. So PHCONA ban gaya. It will go into aqueous layer and phenol will remain into organic layer. Then we will have a neutral FeCl3 test. And I think we have just discussed the neutral FeCl3 test somewhere. Where did we discuss? ये यहाँ पर. Okay, कि कौन देता है कौन नहीं देता है. Same thing. So there is another possibility. Again, we are doing neutral FeC bromine water test. Phenol plus bromine water gives 2,4,6 tribromophenol, which is a white precipitate. ठीक. Helen dye test. Liberman nitroso. Can. As I said, can test देता है, brown color आता है, वो इस चीज का आता है. But NCERT लैम्बैनल ने नहीं दिया, इसलिए तुम्हारे यहाँ उसमें नहीं लिया उन्होंने. I don't know, but otherwise it gives test. Okay. KMNO4 में brown precipitate of MnO2 and solution is colorless. Right. Diazo coupling, I already told you some specific phenols which give iodoform test. These two give iodoform test also. Okay. So that was about POC of phenol. So we did alcohol, we did phenol. Talking of ethers. Let me check ethers.
मैम वो क्वेश्चन आप एक थोड़ा सा करवा सकते हैं
कौन सा क्वेश्चन कौन सा?
उसी
जो अभी
पीडीएफ में जो थे. हाँ
रुक जा फिर एक सेकंड. हम थे कहाँ? अल्कोहल फिनॉल ईथर में ही थे. और हाँ तो यही होगा ये वाला.
यस
ये वाला एकांश है ना. कर देख लो. डिस्टिंग्विश मतलब हमें सेपरेट नहीं करना है, बस एक कोई विजिबल चेंज देता हो और एक ना देता हो, देन वी कैन डिस्टिंग्विश. ओके, दैट इज हाउ वी विल डिस्टिंग्विश. डन? चेक्ड?
यस सर.
और ये तो एक लंबा क्वेश्चन है. कैटेकॉल पे क्लोरोफॉर्म NH वगैरह पूरा ऐसे रिएक्शन लेके. हाँ, ये देख सकते हो तुम कि देखो कैटेकॉल पे क्लोरोफॉर्म NH से पहले मैंने एसिड बेस कराई तो ये फिर विलियमसन के लिए तैयार हुआ O-, और कैसे दूसरी तरफ भी अटैक कराया तो ये बना, ये HH है. ओके, एंड देन एल्डोल कराई, क्रॉस्ड एल्डोल. ठीक. फिर अनहाइड्राइड दिया है तो परकिन कराई और बढ़ गया PCl5 COCl. राइट. अब पिरिडिन दे दी इन्होंने अटैक के लिए, पाइपिरिडिन, तो ये बना पेपरिन. ठीक है, ये भी एक लंबा सवाल है.
मैम
आप
वो
बढ़ते हैं.
CH2I2
हाँ,
वाला समझा सकते हैं.
ये वाले में ये करा ना अपन ने, एसिड बेस ली, फिनॉल अभी अपन ने कहा ना NaOH Na2CO3 इन चीजों से रिएक्ट करता है तो फिनॉक्साइड बनेगा. ओके. और ऐसा कुछ नहीं कि ये या ये, मतलब इनडायरेक्टली अल्टीमेटली विल यूज बोथ, सो इट इज जस्ट फर्स्ट ऑफ कोर्स यही रिएक्ट करेगा.
यस.
फर्स्ट ये क्यों करेगा? क्योंकि ये मोर एसिडिक है ना, para2CHO, तो यही रिएक्ट करेगा. सो O- अटैकिंग CH2. Similarly here also O- attacking, so this cycle is formed. ठीक है. So that was phenols. Let us move to ethers. Ethers में भी है NGP. So ethers में we have only 2 lectures. So let us see. टेस्ट ऑफ हाइड्रोपेरोक्सी ईथर, नहीं हाइड्रोपेरोक्सी से पहले वेयर इज पीओसी ऑफ ईथर अलग से यहीं लिखी हुई है, फिर टेस्ट ऑफ हाइड्रोपेरोक्सी एक ही है टेस्ट इसका ईथर को लेकर। देखो क्या होता है, ऑक्सीजन के एडजेसेंट कार्बन्स पे रेडिकल बड़ा स्टेबल बनेगा ना, सो अगर हम एयर में छोड़ देते हैं ना ईथर को, तो यहाँ पर रेडिकल बन के और एटमॉस्फेरिक ऑक्सीजन रेडिकल इंसर्शन देती है, तो ये बन जाता है, इसे कहते हैं हम हाइड्रोपेरोक्सी ईथर। और इतने पेरोक्सी लिंकेज होंगे अगर एक बॉटल के अंदर, तो वो एक्सप्लोजिव होगी। सो दिस हाइड्रोपेरोक्सी ईथर इज एक्सप्लोजिव। ओके, ethers are extensively used as solvents in lab and were used as anesthesia. If we have old sample of ether, then it is always advisable to test presence of peroxy ether before using it as a solvent. ठीक, अगर हम पुराना सैंपल यूज करते हैं तो हमेशा हमें पहले सैंपल चेक कर लेना चाहिए, अदरवाइज रिएक्शंस में एक्सप्लोजन्स हो सकते हैं। तो पेरोक्सी ईथर बिफोर यूजिंग इट एज अ सॉल्वेंट। टेस्ट ऑफ हाइड्रोपेरोक्सी ईथर, सैंपल ऑफ ईथर लिया, डाइल्यूट H2SO4 डाला, ठीक, और KI डाला, तो कैसे होगा, तो जैसे ही मैं डाइल्यूट H2SO4 डालूंगी वो हाइड्रोपेरोक्सी ईथर वापस डिकम्पोज होगा, नेसेंट ऑक्सीजन निकलेगी, तो दैट इज एन ऑक्सीडाइजिंग एजेंट ना, और वो इस आयोडीन को ऑक्सीडाइज करेगी KI स्टार्च में, और आयोडीन स्टार्च के साथ ब्लूइश ब्लैक कलर देगा। तो इफ यू गेट दैट ब्लूइश ब्लैक कलर, इट मीन्स दैट ईथर वाज ऑक्सीडाइजिंग। ऑक्सीडाइजिंग मतलब हैविंग अ पेरोक्सी लिंकेज। तो अगर हमें पता चलता है ऐसा है, तो फिर हम वो टेस्ट ट्यूब भर नहीं, पूरी बॉटल को इस तरीके से ट्रीट करते हैं, एंड दैट इज हाउ वी अगेन कन्वर्ट दैट हाइड्रोपेरोक्सी ईथर टू नॉर्मल ईथर एंड यूज इट। ओके, या फिर हम ये कर सकते हैं कि जो ईथर का सैंपल है उसको हम Fe2+ डालें, Fe2+ will be oxidized to Fe3+. Okay, and Fe3+ now reacts with KCN and blood red coloration FeSCN whole thrice is obtained. The appearance of this blood red that indicates yes, there was hydroperoxy linkages present. Is that clear? So this was ether ka POC. Now Riemer-Tiemann reaction is asked. So Riemer-Tiemann is phenol. And where in phenol? See, chemical properties यहाँ शुरू ही हो रही है. So phenol, I think this only Riemer-Tiemann. Normal Riemer-Tiemann नहीं लिखा है इसमें, क्या लिखा है? Abnormal Riemer-Tiemann. Okay, so normal कार्बिन ने अटैक करा, पहले तो नॉर्मल कंप्लीट कर ली हमने, और ऑर्थो प्रोडक्ट हमारा मेजर बना, लेकिन सिमिलरली पैरा बन सकता है। डाइक्लोरोकार्बिन इज व्हाट इज अटैकिंग। ओके, दिस इज हाउ द मैकेनिज्म इज। ठीक, चलो फिर अगर एबनॉर्मल की बात पे भी हम आते हैं, दे कैन बी सेपरेटेड बाय स्टीम डिस्टिलेशन। ऑर्थो विल बी द स्टीम डिस्टिल। एक्सेप्शन OH and OMe अगर है तो para product is major, not the three continuous. Okay, OH और OMe में para is major. Evidence of carbene formation, that carbene is formed, ये है para position पे CH-Cl2 का ऐसा attack. This is the evidence of carbene formation. Formation of this compound indicated that dichlorocarbene is the intermediate. ठीक, phenol plus CCl4, KOH H+ अगर हमने लिया तो सिमिलर तरीके से वी कैन हैव सैलिसिलिक एसिड। ये आई आपकी एबनॉर्मल Riemer-Tiemann। हाँ तेजस, एक सेकंड रुकना, मैं ये एबनॉर्मल Riemer-Tiemann एक्सप्लेन कर दूं, उसके बाद बात करते हैं। सो ये यहाँ पर कार्बिन तो वैसे ही बनी जैसे बनती है। अब कार्बिन देखो दो तरफ अटैक कर सकती है, या तो डायरेक्टली माइनस पर अटैक कर दे, है ना, दैट विल गिव समथिंग लाइक दिस। Ultimately, again, I will create a minus so that aromaticity continues. We'll not block this minus. We'll never give H+ to this and close it. Okay, even if it is the medium acidic. And दूसरा हमने है डाइक्लोरोकार्बिन का, ये पाई बॉन्ड पे ऐसा साइक्लाइजेशन देखा। 3 मेंबर रिंग तो अनस्टेबल होगी ये वाली। ठीक, अब ये 1 2 3 4 5 6 मैंने नंबर किया, और ये 3 मेंबर रिंग तोड़ने की, ब्रेक करने की तैयारी करी। तो 5 और 6 में नेगेटिव चार्ज गया, तो 6 और 2 ऐसा पलटा। ओके, ये एंड 2 and 1 ने ऐसा बॉन्ड बना लिया, क्लोरीन निकल गई, तो क्लोरोबेंजीन इज करेक्ट। यही चीज हमने पायरॉल पे करी यहाँ पर। सो QH और NH ने N- बनाया, अगेन डाइक्लोरोकार्बिन इज फॉर्म्ड। सी, अब नाइट्रोजन ने अटैक करके वही 3 मेंबर रिंग हमने फिर से खोली, और ये क्लोरोपिरिडिन, कौन सी क्लोरोपिरिडिन, IUPAC नंबरिंग की बात करी जाए तो 1 2 3 क्लोरोपिरिडिन इज फॉर्म्ड। एंड यस, पायरॉल पे खुद पे डायरेक्ट अटैक से 2 and 5 पे CHO कैन बी इंट्रोड्यूस्ड, 2 and 5 पे CHO can be introduced like this. Okay, so that is how abnormal rheumatoid is done. Yes, Tejas, you were asking something, now you ask. Tejas.
CHO exception, is that always like when any group is connected at ortho, or only in OME?
No, usually I think all
Always.
Tejas.
Okay.
Yes, I can't tell.
Ma'am, does thiophene show this reaction?
थायोफीन पे कभी देखी नहीं, और एबनॉर्मल रीमाटीमन तो बिल्कुल ही नहीं देखी। एबनॉर्मल रीमाटीमन तो फ्यूरैन पे भी नहीं है
मैम, क्योंकि कुछ कुछ बुक्स में लिखा है कि होता है और प्रोडक्ट बना दिया है, और कुछ कुछ बुक्स
नहीं,
में
तो
लिखा
उसने
है कि नहीं
एबनॉर्मल
होता।
रीमाटीमन नहीं कराई होगी, उसने सिर्फ रीमाटीमन कराई होगी। हाँ,
एक मिनट चेक करता हूँ।
हाँ चेक कर, कौन सी बुक है?
मैम, नोट्स में लिखा था, तो जब सर पढ़ा रहे थे तो सर ने किस नोट से दिया था वो पता नहीं, बस PDF
हाँ
में
ठीक
दिखाया
है,
था।
बता तू। काय पे लिखा है? फ्यूरैन पे। हाँ वेदेश्वर।
Ma'am, in volume it was given that thiophene won't show, ma'am.
अच्छा, थायोफिन वोंट शो, वही मुझे भी लगा कि वो नहीं दिखाएगा।
Yes, ma'am. I don't know why it won't show.
It won't show because it is not as activated as pyrrole. This reaction is specific for activated rings. Phenol दिखाता है ना,
Ma'am,
बेंजीन
लेकिन
थोड़ी
वो
ना दिखाता
aromatic नहीं है.
रिमोटिमल।
Is
हाँ,
thiophene is thiophene not aromatic?
no, thiophenes is aromatic. I said activated aromatic, जो एक्टिवेटेड हो। जब बेंजीन ही नहीं दिखा रहा है,
Oh, okay.
कॉलिन नहीं दिखा रहा है, फिनॉल दिखा रहा है।
मैम, नॉर्मल।
हाँ वही,
मैम,
उस
लेकिन
तरह के
वॉल्यूम में लिखा है कि होता ही नहीं है।
सही आंसर इज होता ही नहीं है। इट इज नॉट। अभी मेरे से वेदेश्वर ने भी जो पूछा था कि थायोफिन नहीं होती, थायोफिन नहीं होती, फ्यूरैन नहीं होती। दे डोंट शो रीमाटीमन। रीमाटीमन इज कैरेक्टरिस्टिक ऑफ फिनॉल, पायरॉल, साइक्लोपेंटाडाइन, जो एक्टिवेटेड बिहेव करती हैं, जिन पे नेगेटिव डेंसिटी ज्यादा होगी, अदरवाइज नहीं होगा। हाँ प्रवीण।
Ma'am, the minor product in case of this abnormal product, the one you have written on top,
माइनर, हाँ ये वाला नॉर्मल।
तो वैसे भी नहीं बनता थायोफीन में।
थायोफिन में तो मेरे को ऐसा भी याद नहीं है। एक सेकेंड रुको, लेट मी शेयर द स्क्रीन। अपन अभी किसी बुक में देख ही लेते हैं, और मुझे पता है कि किस बुक में मिल सकता है। क्या तुम्हारे सामने स्क्रीन शेयर हुई?
हुई मैम।
क्या दिख रहा है?
यस मैम।
हाँ स्क्रीन शेयर ना। लेट अस चेक दी बुक्स जो पॉसिबल, जहाँ ये हो सकता है। ये डेटा हमें कहाँ मिल सकता है, कि मिलेगी कि नहीं मिलेगी। बुक्स, फिनार वॉल्यूम 1, इसके हमें हेट्रोसाइक्लिक में जाना है। एलिफेटिक कंपाउंड्स ऑफ सल्फर, नो। हेट्रोसाइक्लिक कंपाउंड्स देखें, एलिसाइक्लिक पे आ गए, सल्फोनिक एसिड पे आ गए, हेट्रोसाइक्लिक। इसमें देखो थायोफिन किसी पेज पे दिख रहा है। हाँ ये रहा, थायोफिन एंड इट्स डेरिवेटिव 741 से 745 में अपना आंसर मिल जाना चाहिए। अब इसका 745 यानी अपन 760 की सर्च डालते हैं, क्योंकि यूजुअली दे देखो 745 746 पे है। चलो चेक करते हैं, अच्छे से नजर रखना, छूटना नहीं चाहिए। तो थायोफिन की प्रिपरेशन है 745 पे, फिर रिएक्शन शुरू हुई। देखो रिएक्शन में ग्रिग्नार्ड वाली बताई इन्होंने, ठीक है, ब्रोमीन एडिशन बताया, fairly readily polymerized by acid and stannic chloride is better than aluminum chloride for Friedel-Crafts. It can be nitrated by fuming nitric acid. Okay, and is readily sulfonated. 2 halogenothiophenes may be prepared between this chlorination. अभी तक रीमर टीमन का जिक्र नहीं आया। हाँ, thiophen may be catalytically hydrogenated. Okay, provided large amount. Various derivatives of thiophen may be prepared by this. यहाँ तक कहीं रीमाटिमन का जिक्र नहीं। थायोफिन डज नॉट फॉर्म सल्फोनियम सॉल्ट्स। हायर कैन बी प्रिपेयर्ड इनडायरेक्टली। ओके, कैन बी डायरेक्टली। थायोफिन इज अ रेजोनेंस हाइब्रिड, और रेजोनेंस हाइब्रिड वाली बात हो गई नहीं, है ना, अभी तक नहीं दिखा। नो, ठीक है, कोई रेफरेंस नहीं है यहाँ पर, जबकि पायरोल में बिल्कुल होगा। प्रॉपर्टीज ऑफ पायरोल, रिडक्शन, ऑक्सीम फॉर्मेशन, ये देखो क्लोरोफॉर्म 3 क्लोरोपिरिडिन, ठीक है, रिंग एक्सपेंशन टेक्स प्लेस। तो थायोफिन में नहीं देने का क्या मतलब है? नहीं होगी तभी नहीं देगा ना। इसमें दिए फ्यूरैन पे चलते हैं, ये रहा फ्यूरैन, पायरोल फ्यूरैन पर ही है ना, ये तो पायरोल पर है। अब आ जाएगा, हाँ, हाँ, ये रहा फ्यूरैन। इसमें भी मुझे नहीं याद है कि कहीं दे रखी है, बट स्टिल लेट अस चेक। नो, तो करेक्ट आंसर मेरे हिसाब से आई विल स्टिक टू दिस कि इट डज नॉट गिव। एटलीस्ट जिस बुक में से ये ओरिजिनली ये सवाल बने हैं वो यही किताब है। ओके, एनीथिंग एल्स? फ्रिडल-क्राफ्ट दे रहा है, फ्रिडल-क्राफ्ट दोनों में लिखी हुई है, बट कहीं पर भी मुझे अभी तक वो नहीं दिखा। तुम्हें दिखे तो मुझे टोकना की यहाँ दिखा। नहीं, रिडक्शन आ गया, सब्स्टिट्यूशन आ गया। ना, okay, coming back to what we were doing. What was the other question? Abnormal remote was last or something else? Let me check in my list. Okay, that was last. उसके बाद तो ये है कि whatever important as per me. हाँ, सो जिन लोगों ने डाउट पूछा था इस पर, आर दे क्लियर नाउ? ओके, कि आइडियली तो जो पूछ रहे थे तुम कि देता है कि नहीं देता है, तो आंसर इज नहीं देता है।
कृपया और स्पष्ट बोलिए।
ओह, मैंने वो फोन उठाया था, उस पर गूगल सर्च आ गई। स्पष्ट बोलिए कह रहा है, चलिए ठीक है। ओके, कमिंग बैक टू दिस मॉड्यूल में, तो तुम्हारे यही दिया है ना कि इट इज नॉट, इट डज नॉट गिव। अरे बोलो भाई, कहाँ गए सारे?
हाँ मैम, मॉड्यूल में वही दिया है कि नहीं शो हो रहा है
कि वो नहीं देता है। ओके, चलो, और कोई डाउट? अब कल जो क्लास होगी उसमें what exactly you want, or else I will go by the sequential notes. Same way you sit with your notes, wherever you need to add anything you add, or else we'll keep moving further.
Yes,
मैम। मैम एक बार पीटीए पेपर भी थोड़ा सा।
पीटी पेपर तो बेटा मैंने मंडे को डिस्कस कर दिया। You are not
अच्छा
there?
वो
I
नहीं वो
discuss. You can ask for the
ठीक है मैं
recording
देख
from
लूंगा
Prasad sir. Okay?
ठीक है
It is there.
मैं देख लूंगा
Done.
ओके
Okay, बच्चों, तो then see you tomorrow. Any other doubt, anyone?
दैट CCl4 के साथ क्या होता है रेमेटिमर में, वो थोड़ा एक्सप्लेन कर सकते
वो रीमाटिमन नहीं है। CCl4 के साथ जो रिएक्शन होती है वो रीमाटिमन नहीं है। उसको अपन मैकेनिज्म की प्रैक्टिस के लिए लेते हैं कि व्हाट इफ वी हैव अ CCl4 देन हाउ द रिएक्शन विल प्रोसीड। सो हमने डायरेक्टली अटैक ले लिया। देख, वी डिडंट फॉर्म अ कार्बीन, डायरेक्ट अटैक SN2, Cl गया, 3 क्लोरीन बचा, फिर 2 क्लोरीन गए, ऐसे
ओके
तो एसिड बन गया।
ओके
ठीक है, ठीक है बच्चों, फिर मिलते हैं कल। अगर अभी कोई डाउट नहीं है तो विल स्टार्ट टुमारो। अच्छा, कल तो तुम लोग इंस्टीट्यूट में रहोगे जब क्लास होगी। अगर तुम में से किसी के पास भी किसी भी तरह का हेडफोन या माइक ऐसी कोई चीज हो जस्ट इन केस, तो तुम लेकर कल आ सकते हो, सो दैट कि अगर कोई डाउट ऐसा हो जो तुम बोल कर सॉल्व कर सको तो बिल्कुल अपन यूज कर सकते हैं। ठीक है, तुम्हें पता ही है कि क्या लगेगा वहां पर, है ना। USB पोर्ट तो उसमें है, अगर लग जाए तो तुम एक बार लेकर आ जाना और प्रसाद सर से बात करके और यूज कर लेना। ठीक।
मैम
हाँ बेटा।
मैम क्या आप पिनाकोल वाला स्लाइड दिखा सकते हो 2 मिनट के लिए?
हाँ बिल्कुल दिखा सकते हैं। एक सेकेंड, अब बस ये है कि कहाँ थी, यहाँ थी, नहीं, यहाँ थी। दिखा तो सकती हूँ, बस मैं ढूंढ रही हूँ कि वो थी कहाँ। Where was it? The only problem is where was it? Pinacolone. So it should be in polyhydric alcohol. Polyhydric alcohol, इसमें क्या है? पॉलीहाइड्रिक अल्कोहल, ये तो इसी में कहीं होनी चाहिए। एस्टर्स फॉर्मेशन ये हमने करा था पिनेकोलोन के बाद ही, नहीं दिख रहा है। एक सेकंड रुक जा, हमने सबसे पहले ही पिनेकोलोन करी थी ना आज।
हाँ मैम।
तो इसमें नहीं है, तो इसमें है क्या? नहीं, ये POC वाला है। लेक्चर 5 लेक्चर 4 में है क्या? हाँ ये रे, देख कौन सा, ये वाली स्लाइड।
मैम वो स्क्रीन इस पे ही अटकी हुई है थायोफिन पे।
अच्छा, अब देख।
हाँ मैम, बस आप दो एक 5 सेकंड रुक रुक के थोड़ा स्क्रॉल कर लीजिए मैम
प्रोसीड
प्लीज।
करूँ? ठीक
हाँ
है,
मिनट मैम।
एक काम करना, मैं रुक के नहीं, तू बोल दिया कर चेंज चेंज, म्यूट
ठीक
मत
है
कर,
मैम, 1 मिनट।
चेंज, है ना।
हाँ मैम चेंज कर दीजिए।
ये ले,
चेंज कर दीजिए मैम।
चेंज
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 चेंज चेंज चेंज। हाँ मैम चेंज कर दीजिए। हाँ चेंज चेंज।
Ma'am, the last page.
द लास्ट कैसे नहीं, ये वाला
Last page. No, the last page. The
लास्ट
before
द
one.
वन विच दिस
The one before this.
दिस
Yes, ma'am. Yes, ma'am. Done.
डन।
Yes, ma'am.
मैम वो लास्ट था आपने जो दिखाया तब।
हाँ ये, फिर ये, फिर ये,
हाँ मैम चेंज
है ना, बस खत्म।
हो गया।
दिस
ठीक है मैम।
इज पिनेकोलोन ओवर। ओके
ठीक है मैम शुक्रिया।
ओके। अरे वाह, इतनी बढ़िया हिंदी, उर्दू, वाह प्रजन। चलो ठीक है फिर, है ना, कल मिलते हैं एंड विल कंप्लीट, कोशिश करेंगे कि पूरा रिवाइज कर लें। किसी को और कोई डाउट?
एक लास्ट वो
क्या क्या कोई कुछ बोला? हाँ
हाँ
प्रवीण,
मैम मैंने वो TSCL का पूछा था वो पहले में।
हाँ बोल, वो तो मैंने बताया था तुझे।
मैम मैम उसका आंसर उससे नहीं आ रहा है मैम, एक क्वेश्चन का
कौन
वॉल्यूम
सा
में।
TSCL का? ये है TSCL का।
हाँ मैम ये एग्जैक्ट क्वेश्चन नहीं, मैंने पूछा था कि OH और SH में क्या प्रेफर होगा अटैकिंग में।
अच्छा हाँ, तो मेरे हिसाब से सल्फर का होना चाहिए, तो तू क्या बोल रहा है?
मैम एक क्वेश्चन है वॉल्यूम में जो कि एक साइक्लोहेक्सेन है और 1,4 पोजीशन में OH और SH है,
हाँ ठीक है,
और फिर TSCL इन प्रेजेंस ऑफ pyridine दिया है,
ओके।
और फिर प्रोडक्ट पूछ रहा है प्रोलॉन्ग रिएक्शन के बाद।
मैं इसे कल देखकर बताऊंगी,
हाँ ठीक है।
ठीक है,
ठीक
कि
है
क्या हो सकता है।
मैम
ठीक है।
इस
SH
लास्ट
अलग से।
वाले स्लाइड में रिंग कॉन्ट्रैक्शन एक्सप्लेन कर सकते हैं?
क्योंकि एंटी पोजीशन चाहिए ना, एंटी पोजीशन पे रिंग अवेलेबल है इस बार, सो रिंग इज कमिंग टू NH2, दैट इज व्हाई यू आर हैविंग कॉन्ट्रैक्शन। सी दिस ब्लू एरो,
यस मैम।
that is why in both cases anti position पे we have ring this time, so you have ring contractions, ठीक।
यस मैम।
Excuse me, ma'am.
हाँ बोलो, कौन?
Is there any exception regarding boiling point in alcohol, ethers, and phenols?
Alcohol, ether and alkane there is,
हाँ,
there is, that will cover tomorrow.
ठीक है
This
मैम।
one 5 carbon का exception है,
हम्म,
5 carbon compound that is given in NCERT,
ठीक है मैम।
है ना। कल अपन जब नोट्स कंटिन्यूएशन में देखेंगे तो वो कहीं ना कहीं एडेड है नोट्स में।
यही पे बता सकते।
हाँ,
कल एग्जाम है।
तो एक बार NCERT देखो ईथर की, वहां पर दिया होगा।
ठीक है मैम।
मुझे ऐसा याद है NCERT में ईथर के वहां पर दिया है कि उसका बॉइलिंग पॉइंट 1 और 2 डिग्री लेस देन हाइड्रोकार्बन है 5 कार्बन का,
हाँ मैम, मुझे 307 309 और कुछ कुछ
है ना।
नंबर याद था।
1-2 डिग्री का डिफरेंस है,
हाँ सर,
और
2 डिग्री का था।
हाइड्रोकार्बन का मोर है और ईथर का कम है ना।
हाँ
हाँ,
हाँ हाँ, तो वो वही एक एक्सेप्शन है, उसी को याद रखना बस।
ठीक है मैम।